Hi, my name is John Lowry, Engineering Manager for Dublin Array and RWE Offshore Renewables Ireland. The following information provides a high-level view of Dublin Array and a walkthrough of each primary element of the project and how we are progressing its design. Dublin Array is a proposed offshore wind farm off the coast of Dublin and Wicklow. The area under development is denoted here by the red line boundary and is approximately 10 kilometres off the coastline. The site comprises of an area around the naturally forming Kish and Bray sandbanks and is approximately 59 square kilometres. Dublin Array will consist of several primary elements which facilitates the generation of a renewable electricity via the wind turbine array, its export undersea and underground to the national transmission grid and on into our homes and businesses. Taking a look at each primary element, we'll start with the wind farm itself. In designing an offshore wind farm, there are numerous considerations to take account of. For example, the environment, natural habitats such as birds and sea life, and what we call physical constraints such as archaeological features, for example, shipwrecks, the seabed itself, its formation and ground conditions, and most importantly, the wind conditions, our primary source of clean, renewable energy. This all helps inform the optimum use of the resource available and design of the wind farm while taking account of environmental and other factors. Over several years, the project team have commissioned many environmental surveys and assessments to inform our design. For example, in 2021, we concluded our geographical campaign, informing our foundation design, export and array cable routing and installation options, as well as receiving our latest wind data, which informs our turbine layout design and performance. Another primary consideration in designing the wind farm is turbine technology development, how this is changing over time and what technology will be available to the project within the project timeframe. This gives rise to consideration of a range of turbines available now and in the future. The trend of technology development is towards larger turbines over time, both in scale and energy output. This has many advantages from an efficiency perspective, as well as maximizing the potential of the wind resource available. Based on current projections and assessment, Dublin Array will consist of approximately a range of 39 to 50 turbines with a possible height of 270 to 320 metres. The energy output range will be in the order of 700 to 850 megawatts, enough energy to supply approximately 800,000 homes and businesses. Offshore substation platforms act as collector stations for turbine array circuits and conduit between the wind farm and the cable on to the shore. It will house the electrical equipment as well as protection, control and instrumentation systems. The current design allows for up to 2 offshore substation platforms. Similar to the wind farm array, the project team have commissioned many environmental and seabed surveys and assessments to inform the offshore cable design route. Based on this and onshore routing considerations, Shanganagh Cliffs has been identified as the preferred landing point, which I will discuss on the next slide. The landfall location at Shanganagh Cliffs, Shankill, will see 2 high voltage AC circuits connected into a transition joint bay, buried below the ground, which will be reinstated once complete. From here, the cables will be fully buried for the entire route from Shanganagh to Ballyogan substation and on to Carrickmines transmission station, the grid connection point. The onshore emerging preferred cable route length is approximately 8 kilometres long and routed primarily within the road network and entirely underground. The cables will be designed and constructed to meet the National Electricity System standards. During construction, appropriate noise and other environmental mitigations will be put in place to minimise impact. As the route identified is primarily through the road network, appropriate traffic management will be deployed to minimise disruption. Trenchless construction technologies such as horizontal directional drilling will be utilised at key junctions and challenging crossing points. This will also aid in minimising disruption. To facilitate efficient construction, temporary construction compounds will be established at appropriate locations along the route. Following completion of the cable installation, all roads, green spaces, will be reinstated. The onshore substation is the link between the wind farm and the national electricity grid. The emerging preferred substation location is at Ballyogan, close to the existing Carrickmines substation. A new substation will be built, which will house all necessary electrical, protection control, and telecommunications equipment required. This station will be connected via underground cables to the existing Carrickmines national electricity grid substation. The onshore substation will be designed and constructed to meet the National Electricity System standards. Thank you very much, and now I'll hand over to Jill.